Assalamu alaikum. Okay, in today's class we are going to solve past paper questions for A levels, that is for the code 9709, and the paper code is pure maths for A level, so it's paper 3-2, and the topic name is modulus. Somehow we also work with log questions, because when you hit the topic of modulus, then you can see you have to also work for the questions in which you have to consider log in terms of modulus. So definitely we must be familiar with the concept of mod first. Like, you people know that modulus means the its representation is definitely represented by two horizontal line, and within the number that is included over here is basically known as maybe constant, maybe as a combination of just like 3x plus 2 constant variables, algebraic expression, anything it could be. So modulus means actually finding the length, and you know that physics phenomena, length can never be negative. If you have already the number inside the horizontal line that is positive, then its answer would also be treated as positive. But if you include with a sign just like mod of -3, so mod have the probability, or you can say it's having the specification that it make the negative term positive. This is a property of modulus. So when you apply -3 mod, its answer would be +3. That's the property. And this is algebraic expression that could be written as 3x plus 2, and its mod value would be considered as 3x plus 2. Somehow we have to deal with different terms whenever we are going to combine these mod equations on both sides, either left hand side or right hand side, whatever it could be. But first of all, you must have to clear the concept of mod in your mind, that mod is basically length, and length can never be negative. So that's why if you have a negative value and you have to find its mod, its answer would be always positive. So in A levels, we have to work for three types of modulus equations. First type suggests that you will see the past paper questions that involve the modulus on both sides of equation. Just like, let me choose an example, 2x minus 3, which is equals to x plus 5. So this is the first type of modulus equation. Be sure to understand my words clearly. I'm using the word equation. While moving the second and third type, you will see you have to work for inequality. And you people know that inequality means less than or greater than. These two things are comes under the topic of inequality. So by the way, for the type 1 I have to work for equality only. So I can see this equation involves 2x plus 3, which is equals to x plus 5, and on the both sides, either left hand side or right hand side, they contains the mod sign. So you can solve this question by using two methods. I'm telling you first method, and second method also I will guide you, and you have to work for that. So first method suggests that you have to apply the square on both sides, that is 2x minus 3 whole square, which is equals to x plus 5 whole square. And students, be sure you will use this method whenever you have mod on two sides of equation. Then you have to work for that, applying the square on both sides. So this is a minus b whole square, this one. This could be written as a minus b whole square, and this could be written as a plus b whole square. So open the terms by using the formula a minus b whole square and a plus b whole square. You can see it would be 4x square minus 2ab would be making as 12x plus 9, and that could be written as x square plus 10x plus 25. Now your work is that you have to make a group of similar terms together. So shift all the left hand side terms or right hand side terms on this side, just like shift all these terms over here, all these things. So when you shift all these terms over here, that gives you 4x square minus x square plus minus 12x minus 10x plus 9 minus 25, which is equals to 0. So let's solve it. That gives you 3x square minus 22x minus 16, which is equals to 0. Now you know that this is a quadratic equation, and quadratic equation can be solved by any method, either factorization, quadratic formula, or completing square. That is the process for AS. So solving this quadratic equation will gives you two values of x, and that value will be the final answer of this question. For example, this is 3x square minus 22x minus 6. For solved by factorization method, it could be solved by only completing square method or quadratic formula. So I'm writing down the formula of quadratic formula, that is b plus minus b square minus 4ac dividing by 2a. This is by ES. You can see this 3 is actually your A, this minus 22 is your B, and this minus 16 is your C. So plug back your values over here and easily you can find the values of x. And students, be sure to memorize the thing that if you have quadratic equations or the mod equation that contains on both sides the term, you can say mod. So either you are getting two values of x, maybe x is equals to 3 by 5 and other x is equals to 1 by 2, something like that. So both answers of x for that situation will be choosable. That would be right. Now the question arises, why? Because this is equation and that contains mod on both sides, so that's why both the answers will be choosable, both the answers are fine, right? So that was all about the first type of quadratic equation. Let's talk about the second type of equation that involves mod. Then we will solve some past paper question. Second type of mod equation contains, for example, you have x plus 2 mod is equals to 3x minus 4. So this is second type of mod equation, and you can see that contains only one side on the mod. Here on this side, this one, the mod sign is missing. There is no mod. Now how you can work? You can work on the similar manner, just like equate the two cases. Here two cases will arise. First case would be x plus 2 could be written as plus 3x minus 4. This is my case 1. Second case would be, you can write the second case over here, that is x plus 2 is equals to minus 3x minus 4. Because mod term can be opened as one term with a positive sign and other term with a negative sign. This one. So you can solve both equations, both cases, in order to find the value of x. So let's solve the first case. X plus 2 is equals to 3x minus 4. So that gives you minus 2x is equals to minus 6, minus minus cancel, and x is equals to 3. This is the first answer from the case number 1. This one. Second one suggests that x plus 2 is equals to minus times 3x minus 4. So that gives you x plus 2 is equals to minus 3x plus 4, and that gives you 4x is equals to 2 and x is equals to 2. So these are two answers for x. So let's plug back both the answers in equation number 1, that is the actual question you have, this one, and check which value of x is going to satisfy this equation. That will be the final answer. So our first choice is x is equals to 3. So put x is equals to 3 in equation number 1 to check what is the either this is satisfying the equation or not. So let's plug back. That gives you 3 plus 2, which is equals to 3 times by 3 minus 4. 3 plus 2 is 5. So mod 5 is always positive because mod is basically representation of length, and length would be positive. I told you in my previous slide. And that gives you 9 minus 4. So 5 is equals to 5. That holds for that. It means that this answer is choosable. Choosable. Let's talk about second one. Second one suggests that x is equals to 2. Put in equation number 1. That gives you 2 plus 2, which is equals to 3 times by 2 minus 4. 4 is equals to 6 minus 4. And 4 is equals to 2. This is not equal. It means that x is equals to 2 is not choosable. So the only one answer is possible, that is x is equals to 3. So x is equals to 3 is best choice. That's all. Now let's talk about the third type, that is the last type of mod equations or quadratic equation or algebraic expression, whatever you want to say. That is type number 3. If you have an equality, means you have a question that is relating to inequality but it contains the sign mod. How you can work for that? This is little bit tricky but not difficult. You have to think about it. For example, you have inequality that contains 3x plus 9 is less than 5x plus 3, and on the both sides of equation or inequality you can say it contains mod. Your first step should be treat this expression, treat this inequality as equality, like make a equality in the equal sign. So when you make it as equal sign, that gives you 3x plus 9 mod is equals to mod of 5x plus 3. Then because it contains on both sides, it contains mod, so you can use first method, that was taking the square. 3x plus 9 whole square is equals to 5x plus 3 whole square. Opening the square by using a plus b whole square formula and compare their element terms together, just like we did in the first part. Yeah, this one, type 1, this one we did like that. So you can compare the terms and solve the quadratic equations by any method, either quadratic formula, completing square, or factorization, whatever that is easy for you. And the method number 1 is opening the square and finding the quadratic equation and then finding the solution, and that gives you two values of x. Method number 2 suggests that if you don't want to apply the square because this is little bit lengthy, you can say it will consume your time. Second method says that if you have inequality, so you can treat it as equation first, and after taking as equation first, you have to find the value of x by taking just only 3x plus 9 is equals to 5x plus 3. Shift the relevant terms together, that gives you 2x minus 6 is equals to 0, and x gives you 3. Or if I would like to find the common term first, that gives you 2 can be taken as common, and inside you have x minus 3 is equals to 0, and 2 cannot be equals to 0, so it means that x minus 3 is equals to 0, and x minus 3 is equals to 0 gives you the answer, that is x is equals to 3. That is the answer. Now you have to check either this answer holds or not. So plug back this answer in the main equation, that is 3x plus 9 is less than 5x plus 3, and check either this x is equals to 3 verify or not. So let's verify it. So it gives you 3x plus 9 mod is less than 5x plus 3. This is my actual question that I have to verify. So let's plug back the value of x over here. So 3 times by 3 plus 9 mod is less than mod of 5 times by 3 plus 3 mod. That gives you 9 plus 9 mod is less than 15 plus 3. 5 times 3 is 15, plus 3 would be as it is. 9 plus 9 is 18 is less than 18. It means that 18 is not less than 18, actually 18 is equals to 18, right? It means that x is equals to 3 is not satisfying the inequality. This choice is not possible. That is going to dissatisfy my condition. This is a tricky point. What do you have to do now? You have to move towards a real line here. You know that here is 0 at the middle point, and you have one answer for this inequality, that is x is equals to 3. So here is 1, here is 2, here is 3. 3 is a point that is not satisfying my inequality, means 3 is not choosable. I have to think about another value that should satisfy my inequality. So other than 3, I have to move toward right to the 3 and left to the 3 to think which value is choosable. If I move to the right of 3, then I have 4, 5, 6, 7, 8, 9, 10. Any value of x would be choosable to the right. So if I choose, if x is greater than 3, if I choose x is greater than 3, then I choose x is equals to, for example, 5. Let's plug back 5 and check either this is going to hold my equation or not. So that gives me 3 times by 5 plus 9 mod is less than 5x plus 3 mod. That gives me 15 plus 9 mod is less than, this is actually 5. 5 times 5 is 25, 25 plus 3 is 28. That gives me 24 mod is less than 24 mod. 24 mod is less than 28 mod. It means that 24 is less than 28. Is it true? This is 100% true. It means that x is equals to 5 is choosable. It's fine. It's work for me. It's fine. Now let's check the another value, that is to the, this portion is fine. This portion is fine. That holds. Let's talk about the other portion that is toward the left. Let me choose the value 0, that is to the left of 3, and let's plug back either this holds or not. If x is less than 3 and x is equals to 0, maybe you can also choose -1, -3, whichever you want to choose. As a random point, I'm choosing the origin. So that gives me 3 times by 0 plus 9 mod is less than 5 times by 0 plus 3 mod. That gives me mod of 9 is less than 3, mod of 3, and 9 is less than 3. Not fine. It not work for me. It means that this portion is not working for me. Not fine. So the only portion that worked for me is x is equals to 5. So the final answer for this question of inequality would be x is equals to 5 is fine, and x is equals to 5 means any value that is x is greater than 3, maybe 4, maybe 5, maybe 6, whatever it could be. So the best choice and whole of the answer for this question would be x is greater than 3 is final answer. You can erase this thing because any value of x that is greater than 3, 4, 5, 6, whatever is working for you for this inequality, so that is fine. So that was all about finding the solution for inequalities. Now we have to work for some questions. In the next recording I will do it. Okay, let's start. So in this slide you can see a lot of questions are there. I think so total questions are 22, and in the next slide I have approximately 15 questions more that was relating to also mod inequalities in terms of log. That will be done after finding the solution of this paper, or you can say this slide. So the question is the first type. I would like to discuss the first type first because during the last class I told you three types of inequality. And in the first type of inequality that contains this type of question, that is under the 10th question number, x minus 2 mod is equals to mod of x by 3. So first of all identify the type. You people know that this is first type of mod equation that contains equality sign and also mod on both sides. And I told you whenever you have such situation you have to equate your equations first. This is from the type 1. You can see 2x minus 3 is equals to x plus 5. So when you have this type of situation you have to equate the equation first and taking the square on both sides to find your answer. Or you can also solve this question by using another method that I told you for the third type, that was about just only comparing the questions. So the statement of question was mod of x minus 2 is equals to x by 3. Let me confirm either this is or not. Mod of x by 3, this is, yeah, fine. Alright. So this is my x minus 2 mod is equals to mod of x plus 3. You can solve this question by using first type square method, means applying the square on both sides. I will guide you two methods and it's up to you. You want to choose whatever that seems easy for you. So this is method 1 that suggests that x minus 2 is equals to x by 3 whole square on both sides. I just equate it and apply the square. X minus 2 can be opened as x square minus 4x plus 4, and that is equals to x square by 9. Do the cross multiplication over here. You can apply the cross multiplication over here and that gives you x square is equals to 9 times x square minus 4x plus 4. That gives you x square is equals to 9x square 36x plus 36. Make a group of similar terms together. That gives you x square minus x square plus 9x square minus 36x plus 36x, which is equals to 0. I shift x square onto the other side and that will become minus. That gives you 8x square minus 36x plus 36, which is equals to 0. This is quadratic equation. You can take 8 as common. Inside you have x square minus 4x plus 4, which is equals to 0. So 8 cannot be equals to 0. only x square minus 4x plus 4 is equals to 0, and you know that this is quadratic equation. When you solve this quadratic equation, you have two answers. I'm writing the answer directly. I figure out through my calculator, but you have to work for that. This is quadratic equation by ES level. So you can solve it by factorization method by making a factor minus 2 and something like that. You know that. So my answers for x would be x is equals to 3 and x is equals to 3 by 2. This is my first answer. This is my second answer. And both answers are fine. Why? Because this is the type 1 question that contains mod on both sides, and there is a presence of equality between them. And I told you in my last slide or in my last class that if you have a type 1 question, then both answer for this question would be fine. So x is equals to 3 and x is equals to 3 by 2 are fine, both. None of the answer will dissatisfy, so they are fine, no issue. Okay, let's go back to the second type of equation that contains mod on one side, this one. Question number 14. So question number 14 suggests that you have the mod of x minus 2, and on the other side there is no mod. There is no presence of mod, so you will find it by second type. Let's find the solution of it. Let me write down the question first. That is mod of x minus 2 is greater than 2x minus 3. Okay, so this is inequality question, but it contains mod on one side. So your first step should be treated it as equation. X minus 2 is equals to 2x minus 3. Now two cases arise. First case would be x minus 2 is equals to positive 2x minus 3, and other case would be x minus 2 is equals to minus 2x minus 3. Let's solve it. X minus 2 is equals to 2x minus 3, and that gives you minus x is equals to minus 1, because 2 is shifted over here, so that gives you minus 1. Minus minus cancel and x is equals to 1. This is my first answer. Second answer is x minus 2 is equals to minus 2x plus 3. 3x is equals to 5 and x is equals to 5 by 3. This is my second answer. Now I have to check which answer is correct, either this one or this one. So let's plug back. Verification process. First of all, put x is equals to 1 over here and check what happens. The question is x minus 2 mod is less than, it's actually greater than, my bad. This is greater than 2x minus 3. So let's check either it holds or not. So 1 minus 2 mod is greater than 2 times of 1 minus 3. Minus 2 mod is means 2, that is greater than 2 minus 3, and this is 1, so 1 minus 1 is 1. Here is 1. 1 minus 2, that is 1, and 1 is greater than minus 1. Yeah, so 1 is greater than minus 1. This holds. Definitely that holds. It means that that is possible, it's choosable. Now you have to talk about the other question, other value, that is x is equals to 5 by 3. Let's plug back. 5 by 3 minus 2 is greater than 2 times 5 by 3 minus 3. That gives you 5 minus 6 mod greater than 10 by 3 minus 3 minus 1 by 3 mod is greater than 310 minus 9. 1 by 3 is greater than 1 by 3. That's not possible. Never choosable. It means that this value is not perfect choice. That dissatisfy. So let's cross it. This one is totally wrong. Not possible. Now check the behavior. This is my real line, and for example, here is my 5 by 3. You have to check the answer to the right of 5 by 3 and to the left of 5 by 3 and check either it holds or not, because this answer is fine, like x is equals to 1 is fine, no issue, it's fine, it's fine. But I have to check for 5 by 3 to the right and to the left. 5 by 3 is approximately 0 point or something, let me check. 5 dividing by 3 is 1.6. It's 1.6661. So to the right it gives me, for example, I'm choosing the value that is 2. I have to check the answer for this 2. And to the left I have to choose, for example, minus 2. Let's choose it and check either which, for which value that is going to be hold. If x is equals to minus 2, then that gives me mod of minus 2 mod is greater than 2 times of minus 2 minus 3. So 4 is greater than minus 4 minus 3. 4 is greater than minus 7. That holds. It's fine. X is equals to minus 2 is also fine. So let's enclosed in a bracket. X is equals to 1 and x is equals to minus 2. These both are fine. It's fine. Let's choose 2. Instead of minus 2, I have to choose 2. So this is 2. This is 2. 2 minus 2 is 0. And 2 times 2 is 4. 4 minus 1 is 4 minus 3 is 1. So here is 1. And final answer would be 0 is greater than 1. Either this holds. 100% no. That doesn't hold. It means that x is equals to minus 2 is also not choosable. Cross it. In fact, erase it. Not possible. So I have only two answers that are possible for that. First one is x is equals to 1 and other one is x is equals to minus 2. So all the question means as a whole, the answer for this question would be all the values of x that are less than 5 by 3 . So this is your final answer, because 5 by 3 less than 5 by 3 involves 1, 0, minus 1, minus 2, and this region is selected, but this region and this region is not choosable. 5 by 3 and to the right of 5 by 3 is not choosable, so let's erase it, and only this portion, the white portion, is not choosable, and to the right or to the left the red portion is choosable. So you can see over here, this is empty ball. This is your final answer. Alright, so you can see a lot of questions are there. I will update this PDF and I will share the link with you of my Google Meet, and you can easily download these questions from there. A lot of questions are there, and all the questions are relevant to two types or three types of mod equation that I guide you in my last class. This question is relating to log. This question number 4. Definitely it's impossible to do it right now because we did not cover the log topic. Inshallah, in the next video I will cover log topic first, and then I will guide you how you can work for that. Thank you for watching. Take care.